This is part 9 of collective communications in MPI. So we have seen the MPI barrier in the case of intra-communicator. Now we're going to take a look at the same example in I barrier in intercommunicator session or scenario. Again, these things are the same. Here we have a request handle. Again, we do the same MPI barrier, pass in the request, and then have the wait call here. But the behavior, let's take a look at MPI CC, MPI I barrier, inter, and then MPI run. The behavior is the same, and the reason for that is the only difference is that in intra-communicator case, the call returns only when all processes in the communicator basically call that MPI wait statement. But for the case of, or MPI barrier basically, but for the case of intercommunicator, processes A will come back from that call only and only when all the processes in group B have that call already called, that MPI barrier. And for group B, the call basically returns only and only when all the processes in group A basically do that call. So in non-blocking, nobody's gonna stop because that's the nature of it. It's the call is returning immediately, but when you call this blocking MPI wait, then that is basically where the semantics are happening. Let's go to non-blocking broadcast. We have MPI IBcast, Vim MPI IBcast. So I'm not going to comment on anything. I'm just going to show you because you have the time to basically pause the video and take a look at everything here. So you have the non-blocking call. You can do something useful. That is the idea of non-blocking communications. And then you can have the blocking call. MPI CC, MPI IBcast.c, MPI run. Again, we had the buffer of 7, and now everybody knows about 7. We have MPI IBcast in the case of intercommunicator. Again, take a look at this. I'm going to slowly go down so that you can pause the video and check if you want to check anything in the code. Again, the same. We have the same buffer 7. We have the root properly set, either MPI root or 0 or MPI proc null. We call the broadcast, we wait for it, and then we print the result. MPI CC, MPI IBcast, inter, MPI run. Then you see that the root process in group A has the buffer of 7. It broadcasts it. And in process group in 2 and 3 in group B, they print the buffer as 7. Now we go back. The next thing is iGather. This is the non-blocking gather, MPI iGather. Let's see. Again, I go slowly down so that you can pause the video and watch the code if something is sort of creepy or you don't know what's going on here. But it's basically the same drill as we had in MPI gather as the blocking cousin of it. But this time we have a non-blocking call, which takes a request. You can do something useful in between, that once these communications are happening in the background, you can do some computation or whatever which is independent from these, and then you can have this blocking call. And then finally, rank 0 or the root process, this is for the integer, and this is for the string that is happening. Again, you can use, oh, beautiful. This is an example of MPI in place. So I go slowly, you can see the code. And finally, once all the gathering is done for the integer buffers and for the C-style string buffers, then you can perform basically in root process, you can print the results. So MPI CC, MPI iGather.c, MPI run. We need to use 8 processes. Okay, this is basically the integer buffers that is received by the root. That's the gather operation. You remember what it works, what it does. It basically gathers information from all contributors, from all processes into a root process, and then finally we print the results. Then this is the C style string that we have. We have a MPI, what's it called? I gather inter. The previous example was in intra-communicator case. This is in inter-communicator case. I'm going again slowly so you can have the time to pause it and see everything. The only difference, as I said, the significant difference is that we are using inter-communicator here. And that's it. So MPI CC, MPI I gather, inter, and MPI run. Again, this is exactly similar to if you go back and watch the blocking versions of the collective communication, you know that what is the semantics here. Okay, the next thing on the line is I gather V. That was the sort of variation which it gives you this flexibility that you can have receive count an array, and you can have also a displacement. So let's go with MPI I gather V. Let's see. I'm going again slowly here. So here we are using two requests because one is going to get used for the integer buffer that is going to get transferred with I gather V. So here we use first request, and then I'm going slowly again. So this is how we set up for the C style strings, and we pass in the second request, and then we wait for first request, we wait for second request. What I could do in return was to only define one request, and here after I did this, I wait for it. So I call MPI wait on my request, and then I use the same request handle for the second non-blocking communication for I gather V. That is also possible. And then this is basically the root process. So let's go with MPI CC. Again, if you don't understand the syntax and semantics, please go watch the blocking version of MPI gather V. MPI I gather V. Let's see. We run it. Then you see basically the same behavior as we had in MPI gather. Now we go to the I gather V, the inter-communicator scenario. Again, I'm going down slowly so that you can pause the video and check different places of the code. The same drill goes here, but the significance is that we are having an intercommunicator, and yeah. Now we say MPI CC, MPI I gather V, inter, we run it with 4 processes, with 8 processes, and this is the gathered received buffer from group B. Of course, in 8 processes, 0, 1, 2, 3 are going to be in group A, 4, 5, 6, and 7 are going to be in group B. Next one on the line is the scatter, which is sort of the inverse of the gathering. So in this scenario, again, if you don't know the semantics, this is, go back and watch the blocking versions. But this is what it does is that one process has all the sort of data, and then it tries to scatter the data based on the ranks of every process. And every process gets its own share of that data. So that is MPI I scatter. Let's see. I'm going again slowly so that you can see everything. These examples, as I said, they're exactly equal to the blocking counterparts, but slight changes have been made to make them compatible with non-blocking calls. mainly, let's say we need to have a request handle. So we generated a request handle here. So everything else is the same in blocking versions as well. But we pass in the request handle here. We can do something useful in between, and then we can wait for it. Root process, other processes, do something, wait there, see a style string, integer, and then print stuff. MPI CC, MPI iscatter.c, MPI run. So you see so the root had this information, and after scattering, every process has its own portion in integers and its own portion in C style strings. Now we go to the scenario that we have MPI iscatter intercommunicator. Again, I go slowly down. Everything is similar to the blocking counterpart, but we have an extra request handle here. And then we pass in here and we pass the intercommunicator instead of the MPI com world. You can do something useful in between, and you need to have this, you must have this waiting call before you access data. This is super important. MPI CC, MPI, iscatter, inter, and I run it with 8 processes. Again, this is what is happening. Group A, send buffer 0, 1, 2, 3, and it scatters it to group B members 0, 1, 2, 3. Based on their rank, they get their own portion of the scattered data. The next sort of non-blocking collective communication on the line is a scatter V. Again, it gives you flexibility in terms of send counts and displacements. I scatter v.c. Again, I go slowly down. Everything is the same, but here we have 2 requests. Everything is the same again. One request is used for the integer buffer, and the next request is used for the C-style string buffer. And then you can do something useful in between. You have to wait for both of them, and then you print the results. Oh. It was iscatter v, .c, and I run it. You see that the same thing. The next version is the iscatter v, the intercommunicator. Again, I go slowly down. Everything is the same. We only have one request here, and we don't have the C-style string here. We only have the integer buffer. I go slowly again so you can see. Again, the significance here is that intercommunicator and the request handle are passed, and we're using iscatter v. You can do something useful. You must have the waiting call before you access data. And MPI CC, MPI iscatter v inter, and running it with 8 processes, again, the same result. Now we move on with non-blocking gather to all, that is I all gather. .c. Again, I go slowly. Everything is similar to the blocking all gather, but this time we're using I all gather, and we are having 2 requests. Again, one for the integer buffer and the other one for the C-style string buffer. You must have this waiting calls, and then you print the results. MPI CC, MPI I all gather, and MPI run. So we have printed only 2 processes results, but this is an all gather. So this means that all 8 processes from 0 to 7, they're going to have the same sort of data. Now let's take a look at the intercommunicator scenario. I all gather. Intercommunicator scenario, I go slowly again. Everything is the same as the blocking one, but we have a request handle defined here. We are using the I all gather. We are passing an intercommunicator. We must have this call here for waiting, and that's it. MPI I all gather and MPI run. Then you see this is how it looks, the results. So all processes in group A, they're going to have the data of group B, and all processes in group B, they're going to have data in group A. So that is all gather. The next one on the line is I all gather V. Again, it gives you flexibility in terms of you're going to have receive counts and displacements. MPI I all gather V.C. Again, I go slowly. Everything is the same. We only have one request handle added here, and then we are using this I all gather with the request handle in an intra-communicator scenario. And we have, let's say, oh, this is what I was talking about, that this time I haven't defined first request and second request. I only used one request. But what is important is that I wait for this. I have to wait for this right here before I use it in another, before I use the same request in another sort of non-blocking call. And then I wait for this one here and I print the results. So I go slowly again. MPI CC, MPI I all gather v.c and run it with, whoops, 8 processes. Again, we only printed results from 2 processes, but everybody needs to have the same results. And then in the case of I all gather V intercommunicator case, I go slowly down. Again, everything is the same. We only have this request handle. We call this I all gather V with intercommunicator and the request handle. We only have the integer buffer here. We don't have C-style string. There we go. MPI CC, MPI I all gather V inter. And then we run it. And you see processes in group A, they have the data of group B, and processes in group B, they have the data of group A. The next one on the line is all to all, I all to all. MPI I all to all dot C. I go slowly again. Again, everything is the same, but we have a request handle defined here. We call MPI I all to all. We pass in the intra-communicator and the request handle. You can do something useful here, and then you must have this MPI wait call before you try to access anything. And we have this example for 2 scenarios, one with a integer buffer and the other one with a string C-style string buffer. And again, note that since I was using one request handle, I must wait here before I use the request handle in another all-to-all call. Or alternatively, I could have a first request, an MPI request, a second request, and passing a first request here, second request here, and I could remove this MPI wait, and then I put after both of these I all-to-all calls, I can put MPI wait for first request and second request. And I go down again slowly. There we go. MPI CC, MPI I all to all dot C, and I run it with 8 processes. The results of 3 processes, 0, 1, and 2 are only shown here. In the case of I all to all intercommunicator, again I go slowly. Again, we add a request handle. We don't have the C style string. We only have the integer buffer in this case. We call this with proper arguments and we pass in the intercommunicator. We must have the wait call again, and then we print the results. MPI I all to all enter and MPI run with 8 processes. This is what you get. The next version is I all to all v. I all to all v dot c. This gives you flexibility to have receive counts array and displacements. As also it gives you the flexibility to have send counts array and send displacements. Again, everything is the same as the blocking cousin or counterpart, but we have a request here and we are calling this I all to all v instead of all to all v. We pass in the intra-communicator MPI come world and we pass in the request. We must have the wait call. We have for 2 scenarios of an integer buffer and a C style string buffer. And finally, we print the results. So you can pause the video. I go slowly down and check the code. But we already talked about this in blocking collective communications as well. MPI run with 8 processes. Again, only the results of 3 processes are shown, but you can have more. The next one on the line is the intercommunicator of I all to all v. The intercommunicator scenario, I go slowly again. Everything is the same, but we have the request. And here we have the intercommunicator and the request. You must wait, and this is how you print the results. MPI CC, MPI, whoops, all I all to all v inter. MPI run with 8 processes. Again, you get these results. The next one on the line is all to all w. This one gives you the maximum sort of flexibility in which that you can also have an array of types. All to all w.c. Oops, sorry. I all to all w.c. I go slowly again. You need to add the request. That's the only difference. And you need to modify this call to I all to all, pass the intra-communicator and the request, do something in between, wait for the results before you access them. You have it for 2 scenarios of a C style string and an integer. You print the results. I go slowly again. That's it. MPI CC MPI I all to all w.c. Running with 8 processors, only the results of 3 are shown here. The next one on the line is basically the MPI I all to all, the W, the intercommunicator scenario. I go slowly again. That's the request we add. Everything else is the same. You pass in again intercommunicator and the request. You only have the integer buffer. You don't have the C style string here. MPI CC MPI. Whoops. Okay. Let me finish this example and then we can go to the next part. Intercommunicator, and then we run it with 8 processes, and this is what we get. Okay, I'm going to see you in the next part.